Good morning, everyone. I would like to introduce our expert who is going to be with us today on the issue of the lithium battery that is proposed for Prince George's County. His name is Dr. Ofadike Ezekoye. He is a professor at the University of Texas at Austin, Cockrell School of Engineering. Good morning, Dr. Ezekoye. Dr. Ezekoye is the Harry L. Kent Jr. Professor in Mechanical Engineering, as well as the John T. McGuire Professorship in Mechanical Engineering at the University of Texas at Austin. He is also the K. and Frank Reese Endowed Professorship in Engineering and the Joe C. Walker Jr. Chair of Engineering. So he wears a lot of hats on that campus. He is the department research in the areas of thermal, fluids, systems, and transport phenomena. I'll say that again. He has a expertise in the Department of Research in the area of thermal fluids systems and transport phenomena. He is a member of the University of Texas Fire Research Group. Dr. Ezekoye is an expert in combustion and heat transfer in high temperature and reacting systems, such as combustion engines, furnaces, structure fires, and in recent years, he has been a PI or a co-PI on funded research from the Department of Commerce, that is the U.S. Department of Commerce, the Air Force Office of Scientific Research, as well as DOE. He has published over 200 journal and conference papers in heat transfer and combustion. His research covers a range of applications from fundamentals of combustion systems to scientific support of the fire service in developing firefighting tactics. What we found of interest was the fact that he has done a number of interesting articles, but one of his publications that he did along with A.D. Anderson is titled Quantifying Generalized Residential Fire Risk Using Ensemble Fire Models with Survey and Physical Data. This was published in the Fire Technology, Volume 54. So I want you to welcome our expert today. Dr. Ezekoye is indeed an expert, but he is able to make his discussion understandable for those of us who are not necessarily technically endowed in his area. So I want you to help me welcome our expert, Dr. Ezekoye. Thank you. And good morning.
Excellent. Good morning, everybody. My name is Ofadike Ezekoye, and I'm a professor at the Department of Mechanical Engineering at the University of Texas at Austin. Ms. Johnson asked me to provide some comments on some of our work on battery energy storage systems.
So I was asked to speak about the PGC Pepco battery energy storage system planning and siting issues, and I'll tell you a little bit about how our work might help influence or think about some of the issues. At the highest level, the energy transition from fossil fuels to renewable energy resources, whether those be wind, sun, tide, requires some method of energy storage. So when the wind doesn't blow or the sun doesn't shine, it's important to have energy still available. And overall, lithium-ion battery systems are probably one of the largest ways that we're going to store energy, but there are other ways that we store energy. And there are plants and existing sites throughout the country that use these types of battery energy storage systems. Having said that, it's important to note that there are many different ways to store energy. We can store energy in compressed air, in dams and pumped hydro, in flywheels, believe it or not. And so depending on the application, there are lots of different ways that energy can be stored for later use. Now, associated with any type of energy storage is the possibility for an accident. So when you have stored energy, there can be sudden and unanticipated releases of that energy. So at the top left here, I'm showing at the turn of the century, essentially, that some form of stored energy was in pressure vessels. So in boiler vessels that contain steam, for example. And because codes and standards were not adequately specified at the time, design of these systems wasn't where it should be, and explosions and accidents occurred, which caused the improvement of standards by which these types of systems were built. On the bottom left here is a dam accident. And so same types of issues. This is the Grand Teton Dam, where inadequate design specifications in terms of the early designs and build outs of some of these types of technologies caused accidents. We hear often about hydrogen as one of the important new ways to store energy. So like electrochemical batteries, hydrogen is oftentimes produced using renewable resources like the sun or wind, and it's stored as a gas. But under the wrong circumstances, it could cause explosions and fires. One of the ways that we're transporting energy currently is through liquefied natural gas. And so LNG terminals are cropping up all over the country, all over the world. And again, sudden and unanticipated releases of that energy can cause significant damage. On the bottom right here, I'm showing a significantly damaged structure. And what it was damaged by was a flywheel energy storage system. So interestingly enough, there are ways to store energy in flywheels. And so this device on the top right is a flywheel system that NASA has developed, but there are many commercial entities that are looking at flywheel energy storage. And you would think on the surface that that would be really safe, but if the flywheel goes out of alignment or something else, then you can have a catastrophic accident. Having said that, what we're really interested in here is the issues associated with battery energy storage systems, specifically lithium-ion battery energy storage systems. When we first started looking at these types of problems in my research group, we focused on explosion and fire hazards associated with battery systems. I'm showing here a utility site owned by Engie in Brussels. And early on, there was a fire about 2017 in one of their energy storage systems, and there was a plume that you see there, the smoke that's coming off of it. And there were concerns by the inhabitants of the village near there that there were some respiratory issues and concerns about that. More recently, there have been explosions in battery energy storage systems around the world, whether in Surprise, Arizona. We've heard about battery fires in Australia, in Liverpool, UK, in California. And so at utility sites, this is a concern and this is an issue. And it has generated improvements in the way we design as a research community and an engineering community these types of systems. Similar issues happen in terms of explosion issues at the commercial and academic level. At the top right here is a fire and explosion that occurred in Australia, in Brisbane. There have been warehouse fires like the one in Morris, Illinois, where it's now an EPA cleanup site. So we have to be careful about how these sites are built, designed, and what's communicated to the community. Increasingly, at the residential scale, we're storing energy in all sorts of ways. So it could be, for example, something as simple as people charging e-bikes within their garages or within their apartments, and that's caused a lot of problems, for example, in New York City in terms of fires that have killed and injured lots of people. There are concerns about toxicity hazards. So up in the top right here is a fire that occurred in the garage, again, with e-mobility devices that caused a shelter-in-place warning for the neighborhood, and some first responders suffered inhalation injuries. So one questions this and says, well, what's the role of codes and standards and the cost of failures associated with these types of accidents? And so overall, there are building codes, and these building codes are important, and there are standards like NFPA 855 that are guiding the decisions and the ways that these energy storage systems are put in place. There are tests like UL 9540A that allow the determination of what sort of issues should be considered in the failures of these types of systems. Now, having said that, failures are modified by codes and standards, but there's a lot of insurance and litigation issues associated with that. So there is a process by which, if a failure occurs, either warranty recalls occur or there's some sort of litigation that helps shape the landscape. For emerging technologies, one of the issues is that as codes and standards evolve, and so that's sort of the stair-stepping of codes and standards, early on, the codes and standards aren't really strong because we don't know what kind of hazards or failures will occur. So most of the things that happen in terms of failures are unknown. But over time, we get more understanding of how failures occur, and we start as a community to correct the codes and standards to create a higher level of safety. Now, having said that, again, human error is always an issue. So my thought is that we are ascending this improvement in design standards for these energy storage systems. So it's important as we talk about batteries to understand that there's what we might consider a cell. So there are lots of cells. So cells are some things like these cylindrical cells all the way to these book-sized prismatic cells in terms of different types of capacities. These are chemical systems. We actually say electrochemical systems. And these cells can be then packaged in modules and then in packs. And so in an electric vehicle, so some of you might have electric vehicles, this is how these cells are packaged. And we all use lithium-ion battery technology because most of us have phones, we have laptops. I actually recently got a energy storage system for my home. We see electric mobility devices all the time. And there's a scaling up of these cells to all sorts of different types of systems, including these energy storage containers. And this is what we're talking about for your community. So the concern is really that under the wrong conditions, cells can fail. So it's rare. Most cells are, especially those procured from what are called tier 1 or high quality battery manufacturers, are really safe. Having said that, there are quality control issues that could occur. So on the top right is the fact that cells could fail because of manufacturing defects. But they can also fail because the charging system might be wrong. So one of the things you should always be concerned about is using the wrong charger for your phone or for any other battery-powered device. Mechanical failure or abuse is if something happens, you drop a phone or you hit a phone with something like a hammer, you wouldn't want to do that, obviously, or you crash a car. So that could damage the battery or the cells, and that would lead to failure. Or fires happen. So it could be an external heating condition that causes the cells to fail. In all these conditions, there's a process called thermal runaway in which the rate of heating within the battery system exceeds the rate at which we could pull heat out of it, and the temperatures continue to rise. And so we see that in terms of fire and explosion events. So my understanding is that there's a 3 megawatt hour battery system that is proposed for your community. And so this is a significant battery system. So each of the, if I'm counting correctly, each of the battery racks within it would be about 250 kilowatt hours. That is larger than, say, Tesla or a large electric vehicle battery. So it's like double or sometimes triple an electric vehicle battery for context. And so these are what we are asking the questions about what the system might look like. Now, I think that Pepco has done a good job in terms of dealing with the explosion hazard. There's a 10-foot high brick enclosure, at least my reading of the specifications around this system. I'm showing here that each rack might look like what you're seeing at the top left there. But the concern is that if the explosion hazard is in fact taken care of, what about the toxicity hazard? And while my group and others have determined what types of flammable gases come off of battery systems, there's much less certainty or accuracy in terms of prescribing what toxic gases come out of it. And there's a parameter called IDLH, immediately dangerous to life and health, that discusses the overall toxicity of some of these components. HF is hydrogen fluoride, hydrogen cyanide, hydrogen chloride, carbon monoxide. And so carbon monoxide is one of the things that is produced in large quantities from these types of battery systems. So I just show one study here that just talks about the emissions from lithium-ion battery systems. And so the point being that there is uncertainty, but a considerable amount of this HF could come off of these types of battery systems. So as we think about it then, from a siting perspective, the types of things, and my understanding is that PEPCO has done some of these analyses. It's important to share these analyses with the community, is that given the proposed BESS location, that there are sensitive infrastructure, sensitive locations near it. And I particularly highlight this, what I understand to be a daycare center. So it's important to understand and for PEPCO to share their analyses of what hazards might be posed to both the daycare center and perhaps to the adjacent homes. The daycare center from Google Maps is only about 300 feet away, so that's a relatively short distance. And the types of things that should be done, the types of things that we've done, and I imagine they've done, but again, they need to communicate, is a hazard mitigation analysis and the fire department response. So there are these things called wind rosettes that say, hey, here are the predominant directions the wind might be coming from. And then they can do computational fluid dynamics or plume analyses to determine where these gases would be going and what the overall response is. I want to stop there and just make my recommendations based upon this last slide. So overall, battery systems are generally safe. In the event of an accident, which although infrequent and low probability, there has to be some sort of response and analysis to understand what the worst credible sort of scenario might be. A plume analysis seems to have been done. It should be shared with the community, and the community can then discuss with experts what their assessment of that analysis might be. The department, local responding department, should provide clarity about what their response would be for some accident that might occur there. And then after the fact, there has to be some understanding of what the post-incident response management might be. What I mean by that is that what needs to be done in terms of cleanup, how do we identify what the stranded energy for the responders might be, and or the overall toxicity of the site. So I hope this provided a little bit of clarity as to some of the issues that one might consider for these types of problems. And if you have any questions, feel free to reach out to me through the PGC Community Service or the League of Women Voters. Take care. Thank you.
Absolutely.
All right, then. We thank you so much. All right, so I am going to do the opening now because I just got a text that the person who was going to do it is ill. So good morning, everyone. Welcome to the League of Women Voters of Prince George's County Issues Forum on the matter of a proposed installation of a lithium battery unit being placed in a section of Prince George's County. First, let me say that the League of Women Voters is a nonpartisan political organization of women and men that encourages informed and active participation in government. We work to increase understanding of major public policy issues and influence public policy through education and advocacy. The League of Women Voters of Prince George's County was founded in 1921 as one of the first local leagues in the United States. My name is Gloria Johnson, and I am co-president of the League of Women Voters of Prince George's County. We have membership information and would like you to join if you'd like. I'd like to introduce you to the persons who will serve as our panel participants today. First, from DPI, we have Mary Giles. Are we able to show her?
Good morning. I'm Mary Giles with Prince George's County Department of Permitting, Inspection, and Enforcement.
And Ms. Giles, I'm just introducing everyone right now. She will bring you back when it's time for your 3 minutes.
Okay.
We have Nabil Wasim, Chief Building Plan Review Division, who will also be with DPI.
Good morning, everyone. How are you?
Thank you. We have Bobby Ray from Maryland Park and Planning, the Special Projects Supervisor. Assistant Fire Chief Christian Wargo. From Councilman Burrow's office, we have Brandon Cooper, who I believe may be trying to get onto the forum. With PEPCO, we have William Ellis and Albert Fan. And of course, you've just met Dr. Isi Coy from the University of Texas, and from the Maryland Public Service Commission, DeAndre Wilson. I'm happy to announce that we have gotten a signed, executed agreement from everyone whose name I just mentioned that they will be bound by the League of Women Voters rules. And basically, I'll give a synopsis. There will be a 3-minute opening starting, and Mimi, if you can take this down with Ms. Giles and Mr. Wasim, who will share.
Gloria, we did not introduce the citizens organizations.
Okay, yeah, and I apologize for that. I know that South Lawn is on. Could you tell me who else is in the back room? Because I can't see them. I'm sorry, Mimi?
I'm just going to add all 3 citizens organizations. We have Patricia Monroe from South Lawn, president of the South Lawn Citizens Organization, Patrice Payne from Livingston Woods, and Herb Jones from IHAC.
Thank you. Each organization will have 3 minutes for an opening. And that will be segment 1 or phase 1. After every organization has had their 3-minute opening, it will be followed by phase 2, which is questions asked from the audience. They will each have 1 minute to respond to the questions. And then the closing will be, each organization will have a 1-minute closing. Okay, and that's basically it. There will be no questions and answers or interface between the various organizations. So with that being said, I welcome you to the Issues Forum on the matter of the proposed installation of a lithium battery in a residential neighborhood in the Oxon Hill, Livingston Road area. And the first segment, we will start with a 3-minute opening from the representatives from PEPCO. We have 2, and they will decide between themselves who, whether Mr. Ellis or Mr. Fan or both, will give the 3-minute opening. Gentlemen, welcome.
Excellent. Hopefully everyone can hear me. Good morning, everyone. William Ellis. I'm the Region Vice President of Governmental and External Affairs. I am joined today by Albert Fan, PEPCO's Manager of Smart Grid and Battery Storage Lead. At PEPCO, we believe our goal is to uplift our communities by creating a smarter, stronger, and cleaner electric grid. You will hear in our presentation how this battery storage system at Livingston Road Substation does just that, along with creating a more equitable and sustainable clean energy future for the residents of Prince George's County. This battery storage project is just an example of how PEPCO has leveraged technology in Prince George's County to meet the goal of a 50% GHG reduction by 2050. We have helped over 13,000 customers across the county install solar in their homes, along with 3,000 just in District 8, with 100 of them also installing a battery storage system at their homes, similar to the one that we're installing in our substation. We're also in the process of installing 140 electric vehicle charging stations in the county, as we know that transportation sector is the largest contributor to emissions. I state these just to illustrate that our commitment to creating a cleaner, more affordable, and more inclusive distribution grid has never been greater, and this battery storage project will help in acceleration of the county's path toward decarbonization. Thank you, and I'll turn it over to Albert.
All right, good morning, everyone. My name is Albert Fan. I'm a Principal Program Manager with the PEPCO team here. I want to present with you, lead off from Will's comments, give a project overview of what our project is. As part of our effort to better serve our customers and build a smarter, stronger, clean energy grid, we are planning a 1 megawatt battery system to enhance service in Oxon Hill, Maryland, with three main goals. One, improving reliability for thousands of customers in Oxon Hill, Maryland. Two, providing a local supply of power during periods of high demand, creating additional capacity on the local energy grid. And three, acting as a backup system should there be an emergency on the grid, especially during periods of high energy demand. This project is part of the Maryland legislative and regulatory initiative to deploy innovative energy storage technology to reduce costs for customers and provide multiple benefits to Maryland's energy grid and those served by it. And we also want to ensure that Prince George's County was brought along in the energy transition and could share in the benefits of new technologies like batteries. So this battery is located next to our Livingston Road substation in Oxon Hill, Maryland. As part of our initial process, we evaluated multiple sites across Montgomery County and Prince George's County. And by far, this project provided the most economic benefits, providing resiliency benefits to establish the growing community in Oxon Hill, Maryland. We're forecasting a substation overload by 2027 without any corrective action. So this battery is very important to prevent that and meet the growing needs of the community there. It's important that we locate this next to the substation because the existing PEPCO property has the infrastructure in place, distribution circuits, telecommunications equipment, protection devices, site safety, security, and operations already in place for that substation. The benefits of the project already alluded to, but overall, this is about reducing the need for additional infrastructure to meet high peak loads. This increases the opportunity for local solar, renewable energy, clean energy on the distribution system with this battery. And this increases overall resiliency of the South Lawn neighborhood. Should there be a system emergency, this battery could supply about 375 residences in the South Lawn neighborhood, in addition to the Oxon Hill Volunteer Fire Department for additional 2 to 8 hours, depending on system conditions. We want to end with that we're committed to helping ensure community safety with this project. From education, training, and code compliance to industry best practices and state-of-the-art safety features, we've done everything we can to make sure this battery is the safest possible that we've seen in the industry. Safety is our #1 priority as a company and always has been. Thank you.
Thank you. Now we will have the next organization is DPI. Ms. Giles.
Good morning. My name is Mary Giles. I'm with the Prince George's County Department of Permitting, Inspection, and Enforcement. I am in the Associate Director in the Site Road Plan Review Division, and we review permits from the standpoint of site development. And next is Nabil Wasim.
Yeah, hello, good morning, everyone. My name is Nabil Wasim, and I manage the Building Plan Review Division at DPI. Some of you may be wondering who or what is DPI? Well, Department of Permitting, Inspections, and Enforcement is DPI, responsible for coordinating and enforcing standards that control what goes on before, during, and after construction. Under the leadership of Director Melinda Balling, our mission is to protect the safety of county residents, businesses, and visitors through efficient permitting, plan review, and inspections to ensure compliance with established building and fire codes. The Building Plan Review Division provides technical support to the development community through the review and approval of plans for residential and commercial constructions. We are a team of engineers and environmental specialists that perform architectural, structural, fire life safety, mechanical, electrical, and health reviews. We utilize codes and ordinances that are adopted by the state of Maryland and Prince George County. We ensure that projects meet the minimum code requirements through a detailed plan review process. Our motto is prevention, and working closely with designers, registrars, architects, engineers who are licensed through the state of Maryland, we strive to achieve compliance in order to protect public health, safety, and welfare. Some of the codes that may apply to energy storage systems from the building code sides are 2018 International Building Code, NFPA 101 Life Safety Code, NFPA 1 with special attention to Chapter 52, the energy storage systems, and Prince George County also has subtitles, Subtitle 4, Subtitle 11, International Mechanical Code, and 2017 NEC. So what is needed for a successful plan review and approval? Well, the most important item is a detailed code analysis, a code pad that shows compliance. Some of the elements that can be required to evaluate the design of energy storage systems are the location of the building from the lot lines, public way, adjacent structures, fire separation distances, fire barriers, spill control, heat and smoke detection, threshold quantities of hazardous materials, fire suppression, venting, devices that monitor thermal runaway, combustible presence on site, and a hazard mitigation analysis. And I'll turn it back to Mary Giles.
I think that concludes our presentation. Thank you.
Organization that we will hear from is Maryland Park and Planning, and that is Mr. Bobby Ray.
Yes, good morning. I'm going to try to set, I just have a few slides, and hopefully I can get these to come up here. Let's see. Is that visible?
Yes, it is.
Okay, thank you very much. Good morning, everyone. As stated, I am Bobby Ray. I'm with the Countywide Planning Division of the Park and Planning. On May 19th of this year, the Prince George's County Planning Board conducted a mandatory referral review of the proposed battery energy storage system. And I wanted to take just a few minutes and explain the mandatory referral process and the purpose of the review. So I think there was some misunderstanding regarding our review and the role of the planning board in that. Mandatory referral is a process for the review of public agency development projects. It's established by state code. Public agencies, as defined by the legislation, include federal, state, county, municipalities within the county, and public or private utility corporations, such as PEPCO. Projects that are subject to mandatory referral range from as small as sidewalk installation, all the way up to a new office building. And so we have various levels of review given the scope of the proposed project, from staff level administrative to a full review, which goes before the planning board. And we do see a number of projects from PEPCO. The majority of these are probably handled administratively by staff. However, given the scope of this project, it was felt that it warranted a full review, and so it was presented to the planning board as indicated. And we do provide notification of the planning board meetings to homeowners associations and other registered associations in the area. The role of staff and the planning board in the review of mandatory referral projects is laid out in the state law. Developments are reviewed in a similar nature to private development projects. We look at those things that are in staff's area of expertise, which include landscaping, design of the facility, site features such as walls, fences, impact on trees, site drainage and other environmental features, transportation related impacts, consistency with plans and land use. And the safety of the facility is not an issue that we reviewed, since it's not really in our area of expertise. We don't have anyone on staff who really has that role, and that's not really the role of the mandatory referral process anyway. And one important distinction between private and public review is that these projects are not subject to zoning because they are public in nature. and my dog is going through my trash can right now. So just some of the major differences between mandatory referral and the review of private development projects. We are subject to a 60-day review period, which starts from the date of application acceptance. If we miss the 60-day deadline, the project will be deemed complete or deemed approved. The recommendations of the planning board and planning staff are not binding on the applicant. If an application is disapproved, the applicant agency can overrule the decision of the planning board and go forward with the project. So that completes my introduction, just to give everyone a background on what the purpose and role of planning board's review was. So thank you.
Thank you. Our next person to speak will be Assistant Fire Chief Wargo.
Yes, thank you, ma'am. My name is Christian Wargo. I'm the Assistant Fire Chief for the Prince George's County Fire Department. I'm in charge of special operations, and which consists of hazmat, and I'm also the D shift duty chief. So I'm running one of the 4 shifts. So I guess with us, we're obviously, if something goes wrong, we're the people that are going to be called. So we've been reviewing not just this building, but buildings throughout the country and other types of lithium ion batteries to make sure our processes and procedures are in place for mitigation. Currently, we are ready to respond to any incident. It would involve a hazmat incident and and lots of other departments, because we would have to probably evacuate the area, set up different hazmat zones, run off, and this process would be a long time putting a battery fire out. You know, they don't happen often. When they do, and we have records of them from, like the doctor said, throughout the country and throughout the world, of when things do go wrong, how we would put them together or put it out. Currently, we are working with the COG region, which is the Council of Governments, to put best practices together to look at equipment to buy, so we can also better mitigate these situations. We'd also have a lot of questions with this because the technology is so new, and there hasn't been that many fires or incidents that we can review and put best practices together. So with this, we would like to be intimately involved in the permitting and code enforcement with this, because the codes just aren't up to date to what they need, to what these buildings need. Yes, they're safe, but what happens when something else goes wrong? You know, we don't know all the other things that are going to happen. So we are prepared right now to run an incident to the best of our ability, protect the citizens of Prince George's County, and be ready for a long duration incident. I appreciate the time, and we can look forward to a lot of questions.
Thank you so much, Assistant Fire Chief Wargo.